Range or horizontal range? Horizontal range. It is horizontal distance traveled by the projectile before it reaches the ground. The horizontal distance traveled by the projectile during the time of flight is called range. This range is attained because of the horizontal component u cos theta. Because of the horizontal component u cos theta, it has traveled horizontally. This is a constant velocity since the acceleration is 0. So, the displacement will be obtained by the product of constant velocity and time. Time is time of flight. Hence, the horizontal range OB is equal to horizontal velocity u cos theta into time of flight capital T. Capital T, by substituting the value of capital T and rearranging, we will get R is equal to u square sine 2 theta by g. R represents the range. Let us derive this relation. Range R is equal to u cos theta into t. But t is 2u sin theta by g. Therefore, R is equal to u cos theta into 2u sin theta by g. R is equal to u square into 2 sin theta cos theta by g. R is equal to u square into 2 sin theta cos theta by g. In mathematics, we have a relation sin 2 theta is equal to 2 sin theta cos theta. So we can write sin 2 theta instead of 2 sin theta cos theta. By writing this, we will get R is equal to u square sin 2 theta by g. R is equal to u square sin 2 theta by g. Maximum range. The relation R is equal to u square sin 2 theta by g suggests that R depends on theta. As theta increases, R will also increase. And beyond 90, when 2 theta is beyond 90, once again the R value decreases. Hence, it has a maximum value. That maximum value will be obtained when sin 2 theta becomes 1. Sin 2 theta becomes 1 when 2 theta is 90 degrees, because sin 90 is 1. Since sin 90 is 1, when 2 theta is equal to 90, then the range is maximum. So, theta is equal to 45. So, for an angle of projection, theta is equal to 45 degrees, the range is maximum. The horizontal range is maximum when theta is equal to 45 degrees. The relation for maximum range, R maximum is equal to u square by g. Since sin 2 theta becomes 1, so R maximum is equal to u square by g. Same range. The horizontal range will be same for two angles of projection if the velocity of projection is the same. For same velocity projection and for two different angles, 60 degrees and 30 degrees, the range is same. Like this, let us derive a general relation for the same range. Same range. For theta and 90 minus theta, the range is same. Let us prove this. In mathematics, we have a relation sin theta is equal to sin 180 minus theta. Sin theta is equal to sin 180 minus theta. For example, if you take sin 120, it is same as sin 180 minus 120, that is sin 60. So the value of sin 120 and sin 60 is the same. The relation for range is r theta is equal to u square sin 2 theta by g. When angle of projection theta, for angle of projection theta, r theta is equal to u square sin 2 theta by g. Let us replace theta with 90 minus theta. The range for r 90 minus theta is equal to u square into sin 180 minus 2 theta sin 180 minus 2 theta by g. By substituting theta as 90 minus theta, by multiplying it with 2, you will get 180 minus 2 theta. So, sin 180 minus 2 theta by g. But sin 180 minus 2 theta is sin 2 theta. Hence, r theta is equal to r 90 minus theta. Therefore, r theta is equal to r 90 minus theta. That is, the range is same for angles of projection theta and 90 minus theta. R 90 minus theta is equal to u square sine 2 into 90 minus theta by g, u square sine 2 into 90 minus theta by g, or r 90 minus theta is equal to u square into sine 180 minus 2 theta by g. Therefore, r 90 minus theta is equal to u square sine 2 theta by g, which is equal to r theta. Examples for same range. Here I have shown the range for different angles of projection. Theta is equal to 15, theta is equal to 30, 45, 60 and 75. If we observe closely, observe the range of 15 and 75. We notice the range is same for 15 and 75. 15 plus 75 is equal to 90. Observe the ranges of 30 and 60. They will have same range. Observe the ranges of 60 and 30. They are the same. The range is same for 60 and 30. 30 plus 60 is equal to 90. So if the sum of the angles is 90, then their ranges are equal. R45 is maximum range. Now observe the maximum heights. By comparing the maximum heights of 30 and 15, what we notice is that the maximum height of 30 is greater than that of 15. The maximum height of 45 is greater than that of 30. The maximum height of 60 is greater than that of 45. And the maximum height of 75 is greater than that of 60. That means the maximum height will be increasing with the angle of projection. But the range reaches a maximum value, and once again the range decreases with angle of projection. For a projection of 45 degrees, the range is maximum. The range is same for two angles of projection whose sum is equal to 90 degrees. If one is theta, the other one is 90 minus theta. Velocity after a time t from the time of projection. Velocity of the projectile after a time t. It is the resultant of two components. One is Vx, the other one is Vy. Vx, horizontal velocity after a time t. Vy is vertical component of velocity after a time t. And V is the resultant velocity. These velocities are shown in the figure. Vx is horizontal and Vy is vertical and V is tangential to the curve. Now let us derive the relation for the velocity. In the horizontal direction, initial velocity ux is equal to u cos theta, acceleration a is equal to 0, time t is equal to t, and the final velocity Vx, let us calculate. Let us take the relation V is equal to u plus at. From this, Vx is equal to u cos theta plus 0 into t. Therefore, Vx is equal to u cos theta. This is horizontal component of velocity after a time t. To find the vertical component of velocity, uy initial velocity is u sin theta, acceleration a is equal to minus g, time t is equal to t, and final velocity is Vy. So substituting these values in the relation V is equal to u plus at, we will get Vy is equal to u sin theta minus gt. U sin theta minus gt. The resultant velocity will be the square root of Vx square plus Vy square. Since Vx and Vy are perpendicular, in vectors we learned that the resultant vector will be square root of Vx square plus Vy square. The angle made by V with Vx is given by alpha, and tan alpha is equal to Vy by Vx. Tan alpha is equal to Vy by Vx. This relation gives the angle made by the resultant velocity with Vx. Summary. In the horizontal direction Ox, initial velocity is u cos theta, acceleration a is equal to 0, and final velocity Vx is equal to u cos theta, and displacement x is equal to u cos theta into t, since the velocity is constant. In the vertical direction Oy, initial velocity is u sin theta, acceleration a is equal to minus g, and final velocity Vy is equal to u sin theta minus gt, and displacement y is equal to u sin theta t minus half gt square. The equation of the trajectory is y is equal to x tan theta minus gx square by 2u square cos square theta. Y is equal to x tan theta minus gx square by 2u square cos square theta. The relation for maximum height h is equal to u square sin square theta by 2g. The relation for maximum height h is equal to u square sin square theta by 2g. The relation for range r is equal to u square sin 2 theta by g. U square sin 2 theta by g. The time of ascent ta is equal to u sin theta by g. The time of descent td is equal to u sin theta by g. And the time of flight t capital T is equal to 2u sin theta by g. The relation for range is r is equal to u square sin 2 theta by g, and r theta is equal to r 90 minus theta. R maximum is u square by g. Horizontal projection from certain height. Let us suppose a body is projected with a velocity u horizontally from a height h. In the figure, h is height of projection, u is horizontal velocity of projection. If a freely falling body is considered from A, it falls to the ground at O. But the horizontally projected body reaches a point at a distance x from O, reaches the point B. So, both are freely falling bodies. For vertical motion, both are freely falling bodies. Freely dropped body falls at O, and the horizontally projected body falls at B following a parabolic path. But both are freely falling bodies. The horizontal distance is travelled because of the horizontal velocity u. We have noticed that the horizontal acceleration a is equal to 0. So let us find the horizontal distance travelled after a time t. So we will get u is equal to u, a is equal to 0, t is equal to t, s is equal to x. In the figure, it is shown as dotted line. Then take the relation s is equal to ut plus half at square. From this, since a is equal to 0, we will get x is equal to ut. So this is the horizontal distance travelled in time t by the projectile, which is projected horizontally from the top of a tower. Vertical displacement of the horizontally projected body. In the vertical direction, the initial velocity is considered as 0 because the horizontal component of u will be u and vertical component is g. In the vertically downward direction, u is 0, a is equal to g, t is equal to t, s is equal to y. So since it is coming down, the initial velocity is taken as 0, a is equal to g, t is equal to t, s is equal to y. By substituting these relations, these values in the relation s is equal to ut plus half at square, we get y is equal to 0 into t plus half gt square, or y is equal to half gt square. Half gt square. By substituting the value of t is equal to x by u, we will get y is equal to half g into x by u whole square. Y is equal to half g into x by u whole square. The relation for path of the horizontally projected body. The relation for path of the horizontally projected body, it is given by y is equal to half g into x by u whole square. Half g into x by u whole square. We notice that the vertical displacement y is equal to half gt square. The horizontal displacement x is equal to ut. From this relation, you will get t is equal to x by u. By substituting, we will get y is equal to half g into x by u whole square, or y is equal to g by 2u square into x square. G by 2u square into x square. This is of the form y is equal to kx square, where k is a constant. G by 2u square is also a constant. So it is of the form y is equal to kx square, which is the equation of a parabola. Since y is equal to kx square represents the equation of a parabola, so y is equal to g by 2u square into x square also represents the equation of a parabola. Hence, the path followed by a horizontally projected body is also a parabola. Time of descent of the horizontally projected body. the time taken by the horizontally projected body to reach the ground. To find this, we have to consider only the vertical motion. We have to consider only the vertical motion. In the vertical direction, initial velocity u is equal to 0, acceleration a is equal to g, displacement s is equal to h, and time of descent t is equal to td. From the relation s is equal to ut plus half at square, we will get h is equal to 0 into t plus half g into td square, or td square is equal to 2h by g. Td square is 2h by g, therefore td is equal to square root of 2h by g. By this time, the horizontal distance travelled will be obtained from the relation r is equal to u into td. Because u is the horizontal velocity, td is the time for which it has travelled. So the horizontal range r is equal to u into td. Therefore, r is equal to u into square root of 2h by g. This is the horizontal distance travelled by the projectile before it reaches the ground. That is the horizontally projected body before it reaches the ground. Horizontal range. The relation for horizontal range is shown in this figure. It is obtained from the relation time of descent td is equal to square root of 2h by g, and the range is given by u into td. So, which is equal to r is equal to u into square root of 2h by g. Velocity of hitting the ground. The velocity with which the horizontal projected body strikes the ground. To find the velocity, we have to find the two components of velocities, horizontal component and vertical component. The horizontal component is u because it will not change. There is no horizontal acceleration. The horizontal velocity will be the same. It is u. The vertical velocity can be calculated from the relation v is equal to u plus at, where t is the time taken to reach the ground, given by square root of 2h by g. So vy is equal to 0 plus gt, since the vertical component of velocity of the horizontally projected body is 0 at the maximum height, at the top of the tower. Therefore, vy is equal to gt. This is the vertical component of velocity when it reaches the ground. So gt is downwards, vertically downwards, u is horizontal, and the resultant of these two velocities is the resultant velocity of the horizontally projected body. Since these two are perpendicular to one another, so the final velocity, the resultant velocity v, will be tangential to the curved path, and its magnitude v is given by square root of u square plus g square t square. V is equal to square root of u square plus g square t square. The angle made by this velocity with the horizontal. The angle made by this velocity with the horizontal is given by tan alpha is equal to vy by vx. Tan alpha is equal to vy by vx. That is equal to gt by u. That is equal to gt by u. So tan alpha is equal to vy by vx. That is equal to gt by u. Velocity of hitting the ground, or the velocity just before reaching the ground, can be expressed in another form. We have vt is equal to g into t, but t is equal to square root of 2h by g. Substituting this, we will get vy is equal to g into square root of 2h by g, that is equal to square root of 2gh. Therefore, the resultant velocity v is equal to square root of u square plus 2gh. And the angle with which it strikes the ground is tan alpha is equal to vy by vx, that is equal to root 2gh whole divided by u. Like this also, we can express the relation for final velocity. Summary. For a body projected horizontally, its initial velocity is u, a is equal to 0 along horizontal direction. So the distance travelled x becomes equal to ut after a time t. In the vertical direction, initial velocity u is equal to 0, acceleration a is equal to g. Therefore, we will get displacement y is equal to half gt square. The resultant velocity v will be equal to square root of u square plus g square t square, and the vertical displacement y is equal to half g into x by u whole square, which gives the equation of a parabola. time of descent Td is equal to square root of 2h by g, and the horizontal range r is equal to u into Td, that is equal to u into square root of 2h by g, and the resultant velocity is square root of u square plus g square t square, and the angle it strikes with the ground is tan alpha is equal to vy by vx, that is equal to gt by u.